This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allowed higher tier paper from the November or the autumn of 2016. One thing I will say is because I've done the intermediate paper, the first 9 questions of the higher tier paper were the last 9 questions of the intermediate paper. So if you want to see those, go to the link below and you can go to the intermediate video and fast forward to those. Okay, so question 10 was the first question of the higher only. It says, draw the enlargement of the triangle below using the scale factor of -2, which I've already highlighted, and a centre of enlargement of -2, 1. Okay, so plotting that correctly would be -2, 1 would be here. And now what I need to do is work out how I get to each vertice of this triangle. So vertice obviously meaning corner. So that one there. And then I need to go in the opposite direction, that's what the minus tells me to, and make it twice as far away. So to get to this vertice that I've highlighted yellow, I go 1, 2, 3 across and 2 down. So rather than going 3 to the right, I now want to go 6 to the left because of the 2-ness and the minus telling me to go the opposite way. So 1, 2, 3, 4, 5, 6. And then instead of going 2 down, I want to go 4 up. 1, 2, 3, 4 here. Okay, now I could just repeat that with all the others. So I know that one is also 3 across, so it's got to be in line with this. It's got to be 6 across, and then it's 1, 2, 3, 4, 5 down. So it's now got to be 10 up from here. So I'm going across to that 6, and then going 10 up. That's 4, 5, 6, 7, 8, 9, 10 would be there. So I've done that one as well. That one is that one, and then this one was that top one. And then finally, I've got this last one to go and work out where that is. So I go across 3 to get to there. So go across 4, 5, and then I go down 1, 2, 3, 4 to get to that one. So instead of going across 5, I want to go across 10. So that put me on -12. And I want to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8 there. So that point that I've just plotted would be the orange one. Okay, so now it'll just be a case of joining those vertices up, and that'll be the question completed. Okay then, over the page onto page 13. We're told a rectangle measures 38 centimetres by 26 centimetres. Each measurement is correct to the nearest centimetre. Now, they usually put that in bold. They haven't. You should be looking out for it. That is telling you that upper and lower bounds has happened. The nearest centimetre means the nearest 1 centimetre. You divide that by 2 to get 0.5 centimetres. And then for each unit of measure, so we're going to have 38 centimetres, to find its lower bound, you would take off 0.5, so 37.5. centimetres, and to find its upper bound you would add on the 0.5 centimetres, which would be 38.5 centimetres. Same with 26, so 26 centimetres, so that would become 25.5 centimetres, and the upper bound would be 26.5 centimetres. Now, in the question it says calculate the least possible area. Well, the least possible area would be having the lowest width and the lowest height. So it would be 37.5 times by 25.5, and that will go into your calculator. SD, that gives me 956.25 centimetres squared. Okay. Over the page, on to page 14. Okay, 12a. Now, this is a bit of a sneaky question. It's a bit of a different way to think about this type of question, okay? Now, when it says factorise, the long way around is to actually expand that out and get x squared minus 14x plus 49, and then try and find some factors like that. It's a much quicker way of doing it, and the quicker way of doing it is looking for anything from the start that's common in both. You see there, you have x minus 7 in both. Okay, so what I am going to do is write out what squared means. So squared means times by itself, so x minus 7 times by x minus 7, and then plus 2 times by x minus 7. I'm now going to take x minus 7 out as a factor. Okay, so to do that, I have x minus 7 there. What times by x minus 7 here? Well, it's times by itself, so it's x minus 7. So x minus 7 times by x minus 7 will give me the x minus 7 squared. And then plus 2, because that's times by 2 will give me that statement there. And then from here, there's actually no need for this to be in brackets. It's not getting times by anything inside, so it doesn't need to be in a bracket within a bracket. So that's effectively x minus 7, brackets x minus 7 plus 2, which I can then simplify again to being x minus 7 and being x minus 5. Okay? The one underneath is actually, no, I would say it's easy, it's not. The first thing you see is you look to see if there's a number or a letter that goes in both. And just at first glance there, I can see that it's an x squared minus a y squared. So they're both square numbers. So this is probably the difference of two squares. However, I know that 12 and 27 aren't square numbers. So what number goes into 12 and 27? The answer would be 3. So it's 3 brackets 4x squared minus 9y squared. Now, within here, you've got something called the difference of two squares. That's a square number. That's a square number. X squared and y squared are both squares. And it has to be a minus in the middle to have what is called the difference of two squares. So what you do is you square root each, and you have a plus in one and a minus in the other. And that would expand out to give me the statement above, and that would be this factorised. Okay? Question 15, it says make x the subject of the formula. So that means you want to get x by itself. Okay? Now we can see that x is on both sides of that as it stands. So what we need to do is expand the brackets and start to isolate the x. So expanding the first one, we get ax minus ab is equal to xc minus xd. The next thing you want to do is get all x's on one side. Now, as it's only there once on that side, I'm going to propose that we bring it all over to this side. So to do that, I'm going to take away ax from each side. So I'm going to get minus ab is equal to xc minus xd minus ax. I'm then going to take x out as a factor from this side. So I'm going to get x there, c minus d minus a. And then that x is touching that bracket, which means it's timesing by it. So I'm going to divide both sides by that bracket to get minus ab all over that bracket. C minus d minus a is equal to x. Okay. There's another way around you can have that if you collected all the x's on the other side, and effectively this is an equivalent statement you could have had. You could have had x equals ab over a plus d minus c in some format, okay? Okay, then over the page, have a quick read of the question. I'll start to go through it in a moment. Okay then, it says points E and F lie on a circle with centre O. The radius of the circle is 10 centimetres. Now they haven't put that on, they normally do, but I'll go and add that in straight away, which means it's also 10 centimetres here. Both of these lines are 10 centimetres because they're the radius. And we're told that the area of the shaded sector is 65 centimetres squared. We're then asked to go and work out what is EOF. So E to O to F would be this angle here, okay? Now, I'm going to call that theta, but you could call it x, you can call it whatever you want. I tend to use that letter. And we also know that this is 65 centimetres squared. Okay? Now, there's a formula that you should know for area of a sector, which is theta, the angle that you have, over 360 times by area of a circle, so times by pi r squared, is equal to the area of the sector. Okay? Now, what I'm going to do is start substituting in the information that I know. So, for instance, I know the radius is 10, and I usually know the angle, but I don't, but I also know the area of the sector is 65. So what I'm going to do now is put in theta over 360 times by pi 10 squared is equal to 65. The next thing I'm going to do is divide both sides by pi 10 squared. So I'm going to get theta over 360 is equal to 65 divided by pi 10 squared. Okay, I've got rid of that times by pi 10 squared there. And then I'm going to times both sides by 360 to get theta is equal to 65 over pi 10 squared times by 360, and that will tell me what the angle is. Okay, would have been nice to give me a bit more space, so I'm starting to run out. Just move the visualize there, we'll have space for the next question. Okay then, so into my calculator goes, fraction button, 65 over pi 10 squared to the side times by 360, and that gives me an angle of 74 point blah blah blah, 74.5. Now just look at that. Does that angle look appropriate? I'd say yes, it does. If it'd been like 0 point something, I'd been worried. If it'd been over 90, I would have been worried. Okay, so 74.5 degrees to 1 decimal place. We're then asked to hence calculate the length of E to F. So E to F is that arc there. Okay. Now we want to use a similar formula, which is theta over 360 times by 2 pi r, which is the circumference of the circle, and that will tell me the length of an arc. Okay. Now we actually know what theta is this time. We're going to say it's 74.48 blah blah blah. We're not actually going to use the rounded answer. We're going to put in the full answer over 360 times by 2 pi 10, and that will tell me what the arc is. Okay, arc length EF. Okay, so into my calculator this time goes, let me just make sure I can see properly here. There we go. So that answer there is key. Now if I press on and I press ands, that number comes straight back. So if I press on again, ands, it comes straight back. Although I shouldn't really be pressing on, I should be pressing AC to have my calculator remember all of the formula that I put in. I can just go and scroll up and down and find out what my previous answers were. Okay, so fraction button, I want that answer, that 74.48 blah 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 answer, out of 360, move it to the side, times by 2 pi 10 in brackets, and that gives me an answer of 13. Okay, so EF equals 13 centimeters. Okay, then question 17, have a quick look at these and I will start to go through them in a moment. Okay then, so we're given what a graph looks like, and we're told that the equation of this graph could be this, and to circle whether that is true or false. Now the key thing here to look at is not only the shape. You should know that an x cubed graph, if I use the space down here, x cubed graphs look like that generically. So a minus x cubed graph would look something like that. Okay, now you can see that shape there. It does look like that shape there. It says it's minus x cubed, and it goes, you want to look at the y-interception. Now that's clearly in the negatives. I just put minus VE, negative. So yeah, for me, that could absolutely be that. Okay, now cubic graphs do tend to take like a bit of a different format when you put in like a minus 9x or like a minus 9x squared minus 9x or something. It would look like this sort of shape. It would look something like that. Okay, at A level you do a lot of that sort of stuff. Okay, so my first sort of look at that, I thought, yeah, that looks all right. But then I looked at the y-intercept here, and I can see that it doesn't go through 0. If it's just got x's in it and it's got no plus 5 or plus 10 or whatever, it must go through the origin, so that's false. It can't, it's purely to do with its y-intercept. Okay, the shape does look like something that could fit that, but because it hasn't got a plus part to it, we'll have to say that's false. This one here, you need to know what this graph shape is. Now, to the minus 1 means it's y equals 1 over x, and that graph you're supposed to know looks something like that, and that's exactly what that looks like, so that would be true as well. And then this one here says the equation of this graph could be x cubed plus 4. Well, again, your x cubed looks like this. That doesn't look like that, and the fact that it's going through plus 4 means that it should be hitting somewhere in the positives, which it doesn't. So that's false. Okay. Okay, then over the page, we're asked to, let me just move the camera again and focus. We're asked to use the quadratic formula to solve the following. Okay, now it's quite clear that in its current format, we can't use the quadratic formula because to use the quadratic formula, it needs to be in the form ax squared plus bx plus c equals 0. So what I need to do is expand out all of this, pull all the terms onto one side, put it equal to 0, then use the quadratic formula. We already know that squared means times by itself, so 3x minus 1 squared means 3x times by itself, and then expanding the second bracket already, because it's quite easy to do, gives me the following. Expanding this one now, 3x times 3x would be 9x squared, 3x times minus 1 would be minus 3x, and then we'll also get another minus 3x, so 2 minus 3x would be minus 6x, and then it would be plus 1 minus 1 times minus 1 would be plus 1 equals 2x squared plus 3x plus 7. We now want to take off 2x squared on each side because we want to have, well, it doesn't actually matter if your a is positive or not, but it tends to make things slightly easier if it is. So because it's gone from there, I need to take them all off this side. So taking 3x off that would give me minus 9x, and then taking away 7 would give me minus 6, and that would leave nothing on this side. Okay, now I can go and state that a equals b equals c equals a is the term in front of x squared, which is 7. B is the term in front of x, which is not 9, it's minus 9. And then c is the term at the end, which is not 6, it's minus 6. Okay, the quadratic formula states the formula is minus b plus or minus the square root of b squared minus 4 ac all over 2a. Now that's told to you on your formula sheet if you didn't know it. The best way to do this now is to change each of those letters to open brackets. Okay, and then literally a is 7, so wherever you have an a, that's where 7's going. So 7's going there, 7's going there. B is minus 9. B was there, and B was there. So it's going to go here and here. Okay, but do not forget that symbol, minus in front of that. And then by process of elimination, C was minus 6, must go in there. And you can see that was the only letter that was missing. Okay, now in your calculator, you'll notice you don't have a plus minus sign. That's because once you plus this square root and once you take it away. Okay, so let's put this into the calculator. So I'll press AC, press the fraction button, minus bracket minus 9. I'll do plus first, square root, minus 9, close bracket squared, minus 4, bracket 7, bracket minus 6, all over 2 bracket 7. I get that answer, I press SD, and I get 1.777 to 2 decimal places, because it did say in the question above, it wants it to 2 decimal places. Now, rather than writing all of that out again, all I do is use the replay button, and I press it several times to the right, and I can delete the plus sign and change it to a minus, and that now becomes minus 0.48 to 2 decimal places. Okay then, over the page, have a quick read and I will start to go through it with you now. Okay then, it says two similar shapes have areas of 700 centimeters squared and 140 centimeters squared. The perimeter of the smaller shape is 83 centimeters. Calculate the perimeter of the large shape. Now it's a little bit harder because you haven't got any drawing there at all. There's no reason why we can't draw this, okay? So the key word here is similar. Now that should be telling you a few formulas which I'll write down in a second. So let's say the shape is that. The smaller one has an area of 140 centimeters squared, and the distance around it, that is 83 centimeters. So the large one would look just like that, but it's got an area of 700 centimeters squared, and they've asked me to go and find out what the distance around this guy would be. Okay, now the formula that you need to use is given as a hint here. It tells us what both the areas are. You need to know the following formula. The small area times by the scale factor squared gives me the big area. Now, because I know both of those, I can substitute them in here to get 140 times by the scale factor squared is equal to the big area, so it is equal to 700. I'm now going to divide by the 140, and you'll notice that I didn't write down the squared as well, and that's because I'm going to then square root that. So that will tell me what the scale factor is. So I find out the scale factor is a really nasty thing. You can see why this is on a calculator paper. It's root 5. Okay. Now, if I'm finding the areas, if I do 140 times by square root of 5, put that in a bracket, squared, that will tell me what the large area is. That tells me that that is 700. Now that's for an area. If we're talking volume, you do the small one times by the scale factor squared. If it's for volume, it'd be small times scale factor cubed is equal to the big one. And if it's a length, which the perimeter is, you just times by the scale factor, okay? So literally, to work out this, we just want to times by the scale factor because it's a line, it's a distance, okay? I'm going to say, so perimeter, so it's nice and clear to anyone looking at my work, would be small times by the scale factor equals the big. We're told the perimeter, the smaller area, is 83 times by the scale factor, which we've worked out is root 5, is equal to the big area, not the big area, so the big perimeter. So we put 83 times by root 5 equals estimate to get 185.6, and that would be centimeters for the big perimeter. Okay. Okay then, question 18 is quite a fussy one. I think it's the last question as well. There's just 2 parts to it. Okay, so give yourself a second to have a read through it, see what you can pick out from it already. But it is quite challenging, this one. Okay then, so let's start by reading the question, then we'll try and work out what's going on. It says, a 9-pointed star with center 0 is shown below. Each side of the star has length x. So that x there is also x there, is also x there, is also x there. There's a lot of x's, okay? The distance from every inner vertex, so inner vertex, the one that's inside, outer being that one there, is 7 centimeters. And the distance from the center from every outer vertex is 10 centimeters. Calculate the perimeter of the star. Now, you should be able to see a triangle there from what they've drawn within a star. And it's the very last question of the paper. We will be using our formulas here. We'll either be using the sine rule or the cosine rule. Now, use the sine rule when you want to know at the end of the question 2 sides, 2 angles. And you use the cosine rule when at the end of the question you want to know 3 sides and 1 angle. Okay? Now, on the face of it, we look at that, and I can see there that I know 2 sides and I want to know a 3rd side, but I'm not told the angle. However, it wants me to know 3 sides. So there's only one formula that I can use that uses 3 sides, which is the cosine rule, which also means we're going to need to go and work out an angle. Okay? Now, we can use a little bit of logic. Let me just put the formula sheet to one side so I can get it easily again. We can use a little bit of logic to work out what that angle must be. Now, if I went and put here, another one there, you can see that I would have made another triangle within it. But I'm looking more at these points now. I'm not going to split those into half. I'm actually going to sort of split them into kites. Okay, now because this is a 9-pointed star and they all meet here, ignore this one in the middle here for now. We can work out what each of these angles must be. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, including that one being split into 2. So if I do 360 degrees, divided by 9, well, we know that anyway, that's 40 degrees. That tells me what this angle here is. Now you can see in this question above, they've actually split that into 2. So what I need to do is then split that into 20 degrees there and 20 degrees there. And I'm starting to form a triangle now that I'm going to just sort of enlarge a little bit. I know that is 20 degrees. I know this is 10 centimetres. And I know this is 7 centimetres. And I'm asked to go and work out the length of x. Okay, so now I can come back to my cosine rule, which is a squared is equal to b squared plus c squared minus 2bc cos a. Now, one thing that you will notice is that starts off with an angle A, and it has little letter a there, B and C there, D and C there. Okay, so that is effectively my A because it's the angle that I know, and this would be little a, and then B and C doesn't actually matter which way round in this question. We'll call the 10B and the 7C. Okay, so using the cosine rule now, we can say that a squared, which is actually x in my question, so x squared is equal to b squared, 10 squared, plus c squared, so plus 7 squared. I know you can't quite see the formula, but I can't write it in otherwise. Minus 2bc, so minus 10 times 7, and then cos angle A, so cos 20. Okay, so next thing I'm going to do is actually write that into my calculator as it looks there. Using that brackets trick will always make sure that my calculator can deal with that. And I get the answer 17.443 blah blah blah. Now you do not round that because we haven't finished the question yet. So then x would equal the square root of that. So we use that ands button from before. So the square root of ands is 4 point. Now don't round that because we still haven't finished the question yet, okay? Now, we've just got to find out what this one tiny little length here is. Okay, we've just got to find out that. That is 4 points, well, if we did round it, just talking about it, 4.2 centimetres, okay? We're asked to calculate the perimeter of the star. So to work out the perimeter of the star, I need to work out how many x's there are altogether. So there's a lot of x's here. Now, use your logic here from what you're told in the question rather than having to go and count them all or highlight them all like I am. It's a 9-pointed star, isn't it? Well, each point there has an x coming off it, so there must be 18 of those altogether. But if you don't believe me, you can go and count them. So then to work out the perimeter, we would do 4.176448 blah, blah, blah times 18. And that will tell me what the perimeter of that shape is. So ands times by 18 comes to 75.2 centimetres to 1 decimal place. Okay, challenging one that wasn't easy. On to the last question, we're then asked to go and work out the area of this. Okay, so if we're using the area formula, we will be using this one here, a half AB sine C. On the very last question, there's no way it will be anything other than using that, okay? So, to work out the area of the star, where you've got this formula here, if I just come back to the formula sheet, if you look where A and B, the sides A and B are, look where they meet. They meet at that angle C, okay? So, now I know that that's 10 and that's 7, and I know they meet at an angle of 20. They're the sides I want to use. I don't want to use X, okay? So, I'm going to say area of one triangle is equal to a half of 10 times 7 sine 20. Okay? So 0.5 brackets 10 brackets 7 sine 20 gives me an answer of 11.9707 blah blah blah. Now you'll notice I haven't rounded it because I haven't finished. I'm asked to work out the area of the star, the whole area. Well, I've just found the area of just this one sliver here. Okay, now again, it's a 9-pointed star. So we've got 9 of these kites, 1, 2, 3, 4, 5, 6, 7, 8, 9 from before. And then each of those kites has been split into 2. So if I was to split all of those going along here, how many of these triangles would we have? Well, you hopefully answered that is 18. So I'm going to say area of star would equal to 11.97 blah, 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 times by 18, which is, and this times by 18, 215.5 centimetres squared to 1 decimal place. Okay, that was the last question. I hope you found that useful. If you did, please hit the subscribe button and you will get access as and when I release more content. Thank you very much for watching.